Okay, we're going to talk about circular motion. I had to change my microphone. Sorry about that. My other microphone broke, but here we have a recap. For linear velocity is how far you can go along the arc S over time. And angular velocity is how many radians you can sweep in so much time. Now be careful, we do need radians for these formulas to work. Now there's a connection between these two different kinds of speeds, angular velocity and linear velocity. The relationship is that the linear velocity is equal to r times the angular velocity. So the relationship involves the radius. Okay, now another thing I wanted to point out is often they give you the angular velocity in RPM. RPM stands for rotations per minute. And we need, for these formulas to work, we need radians per time. Okay, so step one is pretty much always going to be convert your RPM to radians per minute. Okay, so for example, let's say we had theta equals 60 RPM. Right? So if you had 60 RPM, that's rotations per minute. To convert that to an angular velocity that we can use, what we're going to do is multiply by the conversion factor with rotations on the bottom and radians on the top. Now the conversion is that one rotation, there's 2 pi radians. All right? So with that conversion factor, you could see the rotations will cancel, and that'll leave me with radians per minute. All right, so the math tells me the 60 is in the numerator, the 2 pi's in the numerator, so that tells me to take 60 times 2 pi, and I'll be left with radians per minute. Or in other words, 120 pi radians per minute is the equivalent to 60 RPM. But it's this that we're going to have to make use of when we use the formula V equals R omega. Now, another thing I wanted to point out was that you can have the same angular velocity giving you different linear speeds. So, for example, imagine a rock on the end of a 6-inch string, and also imagine a rock on the end of a 60-inch string, right? A much bigger string. And both of these rocks are being spun at 60 RPM. Right, so the same angular velocity for both of these, 60 RPM, right, if you're spinning it around, will produce different linear velocities. So we'll look at the linear velocity there and the linear velocity here. And we'll compare the two numbers. Okay? So same angular velocity, different linear velocities. Watch. V equals R times omega. So the R for the smaller string is 6 inches. So if I put that in 6 inches, the 60 RPM is equivalent to an angular velocity of 120 pi radians per minute. Okay, when I multiply like that, the units that are left are inches per minute because radians, remember, is unitless. So it kind of goes away. And I get 6 times 120 pi inches per minute. That's a linear velocity, which is 6 times 120 is 720 pi inches per minute. All right, so that's the speed of the rock here at the end of the 6-inch string. Now let's compare that calculation to the speed at the end of a 60-inch string. So V equals R times omega there. The radius is 60 inches. And it's the same linear velocity, right? 60 RPM or 120 pi radians per minute. All right, and then the unit here is inches per minute. And so 60 times 120 is actually 7,200 pi inches per minute. Okay, so even though, here you can see, even though the angular velocity is the same, the linear velocity is much greater on the end of a longer string, right? That's how you get different velocities on different circles. Particularly useful when you're dealing with gears and gear ratios. All right, so here we're going to do a pretty typical example. How fast is the edge of a 10-inch diameter disc spinning when the angular speed is 2400 RPM. Now we got to be a little careful. It said 10-inch diameter, and we need the radius. So here's our disk. The disk is going to have a radius of 5 inches. All right, and so this thing is spinning at 2400 RPM, and we want to figure out the linear speed of the edge of the disk. Right? How fast is it going? Typically, they'll want also the answer in miles per hour, and we'll do the conversion there at the end. Okay, so to answer this question, again, your step one is to convert your RPM into radians. All right, so we have 2400 rotations per minute. That's what RPM stands for. So we need to convert that by multiplying by a conversion factor with rotations on the bottom and radians on the top. So we know there's 2 pi radians in one rotation. And so doing that, the rotations will cancel, and that'll leave me with radians per minute. That's what I need. Okay, so the math tells me to take 2400 times 2 pi, which is 4800 pi radians per minute. All right, so step one is to convert 2400 RPM into 4800 pi radians per minute. Okay, so now we can use the formula sort of for our step two to find linear velocity, v equals r times omega. Always. All right, so in this case, the r, the radius is 5 inches. And the omega we found to be 4800 pi radians per minute. And then radians is not really a unit, so you can ignore that. And what we're left with is actually inches per minute. All right, so this is 5 times 4800 pi, I guess over 1 if you want, and that'll be inches per minute. Let me actually do that calculation. And I'm getting 24,000 pi inches per minute. Okay, so that's kind of my answer. That is my answer for the linear velocity, but they wanted the units to be in miles per hour. And so this happens a lot. We got to be able to convert some sort of unit to miles per hour. Let me show you how to do it. Okay, we're just going to do a unit analysis. We have 24,000 pi inches per minute. And so I want hours on the bottom, right? So first thing I'm going to do is multiply by a conversion factor where we have minutes on the top and hours on the bottom. And I know that's 60 to 1, right? 60 minutes in 1 hour. And then those will cancel. And so 60 times 24,000. And so I get 24,000 pi times 60. And I'll be left with now inches per hour. All right, I'm not going to do the calculation yet because I want to get rid of inches. So 24,000 pi times 60 inches per hour. I want inches to cancel. So I'm going to put that on the bottom, and I'm going to bring inches to feet. I know there's 12 inches in 1 foot. All right, and that'll leave me with feet per hour, but that's not where I need to go. I actually need to go to miles per hour. So I'll hit it with another conversion factor with feet on the bottom and miles on the top. In that case, if I do that, the feet will cancel, and then I will be left with miles per hour. Okay, so you need to know that in 1 mile, you should memorize this, there's 5,280 feet. Okay, 5,280 feet in 1 mile. Okay, so now looking at all the math here, all the numerators, I have 24,000 pi times 60. And in the denominator, I have a 12 and a 5,280. Okay, and then that'll be left with, that'll be my miles per hour unit. All right, so let's do that on a calculator. And I get approximately 71.4 miles per hour. All right. So the original linear velocity was inches per minute. I had to do a whole bunch of work to convert that to miles per hour, and there we have it.